Okay, number 18, chapter 22. I'll read from the book and take notes as we go. Factory orders 15.7 kilograms of germanium. I wrote down the number and the units. The density of germanium is 5.32 grams per cubic centimeter. I wrote down density equals number 5.32 grams per cubic centimeters. And I made sure to write it in a numerator-denominator form. Calculate the volume of this material. So I wrote down, where am I going? Volume. In both meters cubed and centimeters cubed. So I wrote that down so I don't forget at the end to put it in both of those units. So that's density. Of course, kilograms is a measurement of mass. So I'm going to write equals mass. And they're asking for volume. So this is obviously a density problem. Density, mass, volume. Density equals mass over volume. Okay, before we apply the formula, notice that the units don't agree. The units of mass, we've got kilograms and grams. So you could either convert this to kilograms per cubic centimeters or this to grams. It'll work either way. It's probably simpler to convert this to grams. So let's do that. 15.7 kilograms. I like to put it in that form. Unit conversion. I'm going to set it up. We want to cancel kilograms. All right, kilograms down there. We want our answer in grams. So I'll put grams on the top. We're going to cancel these units. How many kilograms in a gram, or how many grams in a kilogram? This is a memory one. You should know kilo means 1,000. It's 1,000 grams per kilogram. And just make sure your unit conversion makes sense. You don't want to accidentally write 1,000 kilograms in a gram. That's not right. Okay, so we'll do the math. 3 zeros, 1, 2, 3. 15,700 grams. The next thing you might notice, we could plug in the mass, we could plug in the density, and we will get the volume. I might just do it right the way it is, but it might be more convenient to go ahead and convert that formula so that we have volume as the answer. So we can rewrite this as, we'll multiply both sides by V. That'll cancel. And now we'll divide both sides by D. And then this will cancel. And we'll end up with V equals mass over density. So that's going to give us our answer. So here we go. Volume equals mass. And we have converted to grams over density, 5.32 grams per cubic centimeter. Okay, we're going to do the division with the numbers, and that comes out to 2,950. And then the units is kind of funny. It's grams per grams over cubic centimeters. But if you just consider this and remember that dividing by a fraction is the same as multiplying by the reciprocal, we can instead flip that over and write centimeters cubed over grams. And here we have our grams that we can cancel, and our answer is in cubic centimeters. And lastly, because we want our volume in meters, cubic meters as well, we'll just do a unit conversion down here. We'll start with 2,000 950 cubic centimeters over 1. We need to get rid of that meters to centimeters. So we want meters on the top. We want meters cubed. Oh, we're not going to have enough room here unless I erase that. And we've got centimeters times centimeters times centimeters. That's centimeters cubed. So we're going to need 3 unit conversions. We're going to need centimeters on the bottom once, centimeters on the bottom twice, and centimeters on the bottom a 3rd time. And then we'll have meters on the top, meters on the top, meters on the top, which will yield our meters cubed. So what's the unit conversion between meters and centimeters? Be careful. Well, it's not that hard. 100 centimeters in 1 meter. So 1 over 100, 1 over 100. Do all the math on your calculator. 2950 divided by 100, divided by 100, divided by 100, or divided by 100,0000, and you're going to get 0.00295 meters cubed. And you have answered the question.